Well, how's everybody doing out there? Well, welcome to day 9 of Corona Online School. So this is actually the second or third time I'm trying to make this video. My iPad decided to not cooperate with me and recorded the last video with no sound. So knock on wood, this one does a better job. So today we're actually finishing up our probability section. And so what we want to do is continue what work we were working on the other day by talking about probabilities involving fundamental counting principle, permutations, and combinations. So let's just jump right in and do some examples so we can see kind of what's going on. So in our first example here, we've got Bic pens come in 4 different colors. So we've got blue, black, red, and green with 3 different tip styles, extra fine, fine, and medium. What's the probability of picking one pen at random and having it be a black pen? So in this case, let me just kind of highlight some of the main stuff here. So the way all these problems are going to work is we're going to use the different counting techniques to figure out what kind of goes up on the top and the bottom. So, and this is a little bit different than the probability problems that we've worked on in the past, because in the past, like when we were counting something, it really just meant like counting 1, 2, 3, 4, 5, 6. Like for example, the number of possible die rolls is just 6. The number of ways to flip a coin are 2. So it was just kind of regular old counting. So here, it's going to take a little bit of work to actually do the counting part, because it's going to either involve a fundamental counting principle, a permutation, or a combination. So that's one of the things you want to do first whenever you dive into one of these problems, is kind of identify what is the overall technique that we're going to use. And so in this case, this one is just crying out for fundamental counting principle, which I'm going to abbreviate FCP so I don't have to write the whole thing out. And so once we kind of identify what we're looking for, then what we want to do is kind of break down each of the parts, the top and the bottom. So in this case, what we're trying to do is figure out what's the probability of getting a black pen. And so the way we want to do this is we want to first, I'm going to fill out the bottom first, is figure out what's the total number of all possible pens that we can find. And that's usually what we were doing in the last section when we were calculating the permutations and the combinations. It was usually the total that we were trying to figure out. The top's usually a little bit trickier because some kind of a restriction is going to be put in place, and it's going to make it so it's a little bit different. So for example, for the top, we only want to get the total number of just black pens in this case. So normally the way I do these, I usually just start with the bottom, because typically, again, it's going to be the easier of the two. And so in this case, we've got 2 categories. So we've got the pen color and the tip style. So if we were calculating the bottom, since I've got 4 possible pen colors, I would get a 4 times 3 possible tip styles. So I'm going to get 4 times 3 on the bottom, which is the total of all possible pens that I can make. Now for the top, since I only want the black pen, then that means I want to eliminate blue, red, and green as a possible pen color. So the only possible choice I'm going to get is black. So in this first number, instead of getting a 1 or a 4, I'm just going to get a 1, because I'm restricting it so that black is the only possible color that I get. But I can still have a black extra fine pen, or a black fine, or a black medium pen. So those are still available, so I'm still going to get a 3 as my second choice for the top. So now that we've got everything kind of laid out, now just multiply across the top. So 1 times 3 is 3, 4 times 3 is 12, and this reduces down to 1/4. So the probability of getting a black pen would be 1 out of 4, or like 25% in this case. All right, everybody okay with that? Perfect. All right, so let's move on to example 2. So example 2, we've got playing cards. And so a standard deck of playing cards has 52 cards. Suppose you're dealt 3 cards. and it asks us a bunch of different probabilities. So before I get started on the probability part, so in general, like 99.9% of the time, card games are always going to be combinations. Because if you think about it, if you play cards, for example, usually if someone deals you a deck or a hand of cards, the first thing you do is you start rearranging the cards in some other order. Maybe you arrange them, from lowest to highest, or put all the spades together and all the clubs together. But either way, you're able to move them around, and you still have the exact same hand. So with cards, unless it specifically says order matters, order never matters. So for pretty much any time you're dealing with a card game, it's going to be a combination. So just kind of keep that in mind. So that means when I'm going to calculate these probabilities and I'm trying to figure out the totals, I'm going to use combinations for all my different scenarios. All right. So with that in mind, now that we know that we've got a combination, we want to find what's the probability that all three of our cards are queens. So in this case, the probability of 3 queens. So again, just like above, I kind of like to write the words out to just remind me of what I'm actually trying to count for the top and the bottom. So again, I'm going to start with the bottom because the bottom is usually the easier thing to figure out. So the bottom is just a total number of 3 card hands, so with no restrictions whatsoever. So it could have queens, it could have aces, it could have twos. So any possible 3 card hand you can deal me, it's going to be represented in that bottom. Where the top is going to be our restriction, because in this case we want to make sure that it only involves queens. We want our hand to just contain queens. So the total number ways to get 3 queens. So again, I'm going to focus on the bottom first because it's usually the easier thing to do. So with the bottom number, the total number of 3 card hands is going to be, again, it's a combination. So there's 52 cards total. So that's going to be our first number. And then how many cards are we choosing? We're choosing 3. So in this case, our bottom number would be 52C3 in this case. All right, so what about the top? So again, we're still choosing 3. So I know my second number is still going to be a 3, but what number goes in the front? So the main thing I need to remember is I want this top number to actually occur. I want it to actually happen. So I need to make sure that the only cards that I'm actually allowed to draw from are just the queens. So in this case, since there's only 4 queens in the deck, those are the only cards that I'm actually going to draw from in this case. So my probability of getting 3 queens would be 4C3 divided by 52C3. And I forgot to bring my calculator again, so feel free, throw this in the calculator and calculate it yourself. Now you may have to type the top number first in the calculator first, write it down, then type the bottom number and write it down, and then just write that as a fraction, because this number is going to be pretty small, so it may not like when you try to type it in the calculator. So if you need to, just type the top number in first, write it down, type the bottom number in, and then write it down, and go from there. All right, so that looks good. So now let's look at the next one. So what's the probability that all 3 cards are hearts in this case? So again, same start. So probability of 3 hearts. Kind of a heart, maybe. So again, I'm going to start with the bottom because it's not going to change. And so that's one of the other cool things if you happen to have like a multi-step problem like this one. If you're always drawing 3 cards, like in this case, my bottom number is going to be the same every single time. So that 52C3 is just going to be repeated over and over and over, however many parts I've got to this problem. So again, my bottom is just the total number of 3 card hands. And then my top number is going to be the total number of ways to get 3 hearts. So again, just like I said before, the bottom number is going to be exactly the same. So I'm just going to go ahead and write it down. So 52C3. Ooh, I don't like that 52 though. Let's try that again. That looks better. But the top number, so again, we're still choosing 3. So I know I can go ahead and put the C3. But what's going to be my first number? So again, I don't want anything other than hearts. I don't want spades, clubs, things like that. So I only want to choose from hearts. So there's 13 hearts in the deck. So that's going to be the total number that I choose from. And so again, I'll leave this for you to calculate. And so again, if you need to, just calculate the top first, write it down, calculate the bottom, write that down. All right. So finally, last one for this example. What's the probability that all 3 cards are red cards? And so again, same thing. I'm going to write down the bottom kind of description first. So again, it's the total number of 3 card hands. And then the top is just the total number of ways to get 3 red cards. All right. So again, just like I had mentioned before, bottom number is always the same in this case. Still 52C3. My top number is still going to be something C3. And so what's our total? So again, we want to restrict our deck to just being red cards. So in this case, I don't want any black cards. So there's 26 red cards in the deck. So I want to put a 26 there in the beginning. All right. That makes sense to everybody? All right, perfect. All right, so let's look at one last example here, and I'll let you guys practice. So example 3, so we're going back to our FCC movie marathon. And so again, if you remember before, we had 4 movies that we were trying to show: action, comedy, drama, and horror. But now someone's actually brought a 5th movie, a thriller, into the mix. And so the way we're going to figure out what order the movies come in, we're just writing all the names down, throwing them in a hat, and then pulling them out at random. And so the goal is we want to figure out what's the probability that the thriller is the 4th movie and a horror movie is the 5th movie in this case. So if you remember from last time, this was a permutation, but another reason it's a permutation is because we've put a ranking to these movies. You know, we've got a 4th place, a 5th place, so there's an order to it. So this is definitely a permutation. And so what we're looking for is what's the probability that the thriller is 4th and the horror movie is played 5th. And so again, I'm going to write out description-wise like what each of these top and bottom numbers are going to represent first, and then we'll calculate the probability. So again, I like to do the bottom number first because it's usually easier. So the bottom number is just how many ways can we just play all 5 of these movies in different orders. So how many ways can these 5 movies be played? So again, in this case, there's no restriction. So the horror movie could be 1st, the thriller could be 3rd, they could be anything. So there's no restrictions to the bottom. But in the top, we want to put the restriction that the thriller is 4th and the horror is 5th. So how many ways... Whoops, how many ways, sorry. Can the movies be played with the thriller 4th and the horror 5th in this case? All right. And so again, I'm going to calculate the bottom first. So I'm going to do this using the box method because I kind of prefer the box method over using the P formula. But at the end, I'll show you, if you do like the formula and you like using your calculator, I'll show you how you can type it into your calculator using the P formula. All right. So again, in this case, since I've got 5 movies and I want to play all 5 of them, then I would write down 5 boxes, one for each time slot for the movies. And again, since I'm not allowed to repeat these, I've got 5 choices for which movie could be played first, then 4, then 3, then 2, and then 1. And then on the top, same thing, I still have 5 time slots for which these movies can be played. But in this case, what we've done is we've already said, well, the thriller we're going to put in is the 4th position, the horror movie we're going to put in at the 5th position, and so we really only have control over those first 3 positions. So keep in mind, even though there's 5 movies total, we've already used 2 of them. So when I say how many choices do I have for what goes in that first box, there's just 3, because we've already placed the thriller and the horror. We know where they're going. So it just leaves us 3 choices for what can go in the first, then 2 choices for what can go in the second, and then finally 1 choice for what can go in the 3rd position. So now I just want to multiply these guys across, ignoring the T and the H. So 3 times 2 times 1 is 6. 5 times 4 times 3 times 2 times 1 is 120. And so finally the probability of drawing the 4th being the thriller and the 5th being the horror movie is 1 over 20 in this case. And if you wanted to calculate it as a decimal, you can just throw it in the calculator. All right. Now, if you wanted to do this using the P formula, so again, I'm going to start down at the bottom. So notice we've got 5 movies and we chose all 5 of them. So in formula form, this would just look like 5P5. So there were 5 total movies, and we played all 5 movies. We chose all 5 movies to play, so it'd be 5P5. So on the top, so again, even though there were 5 total movies, remember by placing these, we sort of lost any control over them. So we only have 3 possible movies to choose from in the beginning, and we played all 3 of those movies. So in formula form, this would look like 3P3 divided by 5P5. And again, you could type that in your calculator, and you should get same thing as 1 over 20 in that case. All right. Well, there's a couple in here for you guys to practice. So jump right in, have some fun practicing with these guys. These can be tough because, again, sometimes it's hard to tell whether it's a combination or a permutation. So if you get stuck on any of these, feel free to let me know, ask questions. I'll be around the computer all day to answer stuff. So good luck, have fun, and then when you're done, come back and we'll watch the 3.6 video and we'll finish up probability.